AI can learn anything, literally. It's a mathematical guarantee. In theory, there is an AI that can achieve sentience, achieve immortality, predict weather years into the future perfectly, simulate the physics of a whole universe, and eliminate poverty and war. AI can do all these things to 100%, 90%, 80%, any desired degree of accuracy. But the question remains whether it's possible or not in practice. Can we find it? Is it feasible? Can we realize this in practice? And the answer is often no. It's simply too hard to find this magical model that can achieve all these things, even when the theory guarantees that it exists. This idea is called the universal approximation theorem, and it states that a neural network, which powers modern AI models like ChatGPT, Claude, and Gemini, with at least one hidden layer, can learn anything, can approximate any function to any desired degree of accuracy. It doesn't matter how complex this function is, how easy it is. It could be something really complex, a very complex task, like approximating the physics of the universe, or something very easy, like fitting a line. But it still guarantees that there is an optimal model that can achieve any desired degree of accuracy. But how do we find it? As previously mentioned, it's often very hard to find this model in practice. We often fail to converge to the global solution and often achieve a weaker solution instead. To understand this better, think about AI optimization as searching, with the AI as a mountain explorer. They sit at the top of the mountain, and their job is to go to the very bottom, to the valley. How do they figure this out? We want to find the one that goes to the very bottom of the valley. In machine learning terms, this is the loss landscape, where loss is a measure of how wrong the model is. If the loss is bigger, then the model is more wrong. This is not what we want. We want the model to be as accurate as possible. So we want the loss to be as small as possible. We want to minimize the loss. And this is the whole idea of machine learning. Out of all possible models, we seek the one that is the best. That is, the one that can minimize this loss the most. More rigorously, we want to find the model that minimizes the empirical risk and the expected risk, even though one is only computable in practice. Even though there exists this optimal model, it's very hard to achieve because of three main reasons. The first is data. The model is dependent on the quality, scope, and diversity of the data. If the data is bad, the model is most of the time also bad. If the data is too small, if there's only 10, 20 samples, then the model will fail to generalize. It will likely overfit without any special techniques like regularization. If there's data bias, models will usually assume that bias too. So it's about data quality. That's the first point. The second point on why this is elegant in theory but very hard to achieve in practice is the optimization itself. AI uses an optimization method called gradient descent, and modern optimizers gradient descent methods like the one that ChatGPT uses, they all land in local minimum and rarely end up in the global minimum, the one that represents the optimal model or the one we want to achieve, the valley. This is because neural networks and the loss function that they use operate under a highly non-convex landscape, a very complex one with all sorts of bumps, hills, and seemingly small valleys that are actually not the lowest value. This leads to the AI getting fooled and getting stuck in the local values, the local minima, when the end goal, though also impossible or almost impossible goal, is to reach the global one. So, in summary, AI is about optimization, and the universal approximation theorem that comes with it, while elegant, guaranteeing that there is a model that can fit anything to any desired degree of accuracy. There's an optimal model for anything. This is often very hard to achieve in practice because of the reasons mentioned in the video.